today. Okay, so again, as I mentioned, I'm going to be recording this part of the session. If there's anybody who has an objection with me recording or for us to do a recording, then please say so now. 5, 4, 3, 2, 1. Okay, so the topics that we're going to be talking about now are have to do with representation of values in either in the number line or in the Cartesian plane, and working with these values and some expressions that can help us relate these values. So the two that we're going to start off with is the definition of the distance between two numbers or 2 points in the number line, and the definition of the midpoint between two numbers. Now, how does this relate to the previous topics? It relates because the definition of the distance between two numbers is in the number line is it's going to be the arithmetic difference between these numbers, and it's going to be the absolute value of this. So this is another application of the absolute value concept. So if I have two numbers that are in the number line and I want to know the distance between these two, it's going to be the difference between these, and it's going to be the absolute value, because I'm really not interested in the sign. I'm interested in how many units or how long is the section between those two numbers. And then the definition of the midpoint between two numbers is going to be the addition of the numbers divided by 2. Okay, and let's see a couple of examples of this. And so the distance and midpoint between 2 points. Now, it says find the distance and midpoint of the line segment joining the numbers -2 and 5. Okay, so how could we do this? Let's do some drawing here. So let's draw a number line. Okay, let's do it graphically, and then we're going to validate with the formulas. Let's do a number line, and I'm going to put the 0 here. My number lines are kind of curved, but I think you get the idea. And let's mark the numbers 1, 2, 3, 4, and 5. 1, 2, 3, 4, and 5. So this is one of the numbers that we're talking about. On the other side, I'm going to also mark 1, 2, 3, 4, 5, but this is going to be a -1. Then we're going to have a -2, a -3, a -4. I'm going to put here, and a -5. Okay, so they're asking us to locate the number. They're asking us to identify the distance between those two numbers, which in this case is -2 and 5, and also the midpoint. So one of the numbers is here. This is -2 right here. And the other number is 5. And so can somebody tell me, just looking at this graphical representation, what is the distance between these two values? Just the distance between these two in units. Can somebody tell me, please?
7.
That's Andrea.
7.
Thank you very much, Andrea. Perfect. It's 7. And how did you find that, Andrea? Sometimes the simplest, the answers to the simplest questions are the most complicated. So Andrea, how did you identify that it's 7? Are you there, Andrea? Or did we lose you? Andrea, are you there?
My internet, I'm having trouble with my internet.
Oh, sorry about that. Don't worry, but just quickly before your internet goes, how did you identify that it's 7?
I count from -2 to 5, and there were 7 units.
Yeah, again, it's a simple it's a simple answer, and it's correct. You counted how many points there were between -2 and 7. Did you care that one was a -2 and the other? Did you care that one number was negative and one number was positive? Not really, right? You just counted the spaces and you found that it was 7. That's correct. Just before, because I don't want just because we're going to take advantage that you're participating here, Andrea. So it's 7. The distance between the 2 points is 7. That is correct. Can you kind of identify where is the middle point? Approximately.
Like in the 2.5?
Well, it's actually, let's see how we can calculate the midpoint here. So we've got 7 units. So if we've got 7 units, the midpoint would have to be 3.5 units of these, right? So if I go here, it's 1, 2, 3.5. So it would be right around here. And this value here is 1.5. How did I know that? I know that because the midpoint, if it's 7 units, the midpoint has to be at the half of those 7 units. So it would have to be 1, 2, 3, and 0.5. So this would be the midpoint and this would be the length, okay? And so how can we calculate that using the expressions that we just saw before? Well, the distance between the numbers would be the absolute value of B, which in this case was 5, minus A, which is minus 2, okay? And this would be the absolute value of 5 plus 2. Why is it 5 plus 2? Because minus times minus is plus. This would give us the absolute value of 7. And the absolute value of 7 equals 7. Okay. And on the other hand, if we've got the midpoint, then we're going to have A plus B. A is minus 2. B is plus 5 divided by 2. This is going to be equal to minus 2 plus 5 is 3. And if we divide 3 by 2, this is going to give us 1.5. Okay. So it's very easy to apply the expressions that relate the distance between 2 points and also the midpoint. Now, up to this point, we're working in the number line. So we're just working in 1 dimension. But we're actually, all of these expressions have their versions that are the 2-dimensional kind of. They're actually the 3-dimensional versions also. But in this course, we're going to be only working with 2 dimensions. Okay. So, so questions. Is this any questions here? Is this clear? I think I've got some questions here in the chat. Mm-hmm. Okay. Now, thank you very much. Thank you very much, Lisa, for letting me know about Andreas' internet problems. Thank you. Okay. So questions here. So this is relatively direct. We can find the solution there. Okay. And let me just give me one moment here so I can unhide some slides because that's why they're not showing here. So give me one moment. Okay. So some of the slides are hidden. Let me just unhide these quickly. Okay. There we go. There we go. Okay. And so if we go back here to the presentation, then we do the calculations, okay? And so which were the ones we did previously, okay? And now let's talk a little bit about the coordinate plane, okay? So the coordinate plane, which is it's a system that's formed by or it's an extension of the real number line. Okay, it's an extension of the real number line, where a coordinate system is formed by two perpendicular lines, and it's basically taking the number line, which is horizontal and represents numbers from minus infinite to infinite in one dimension. It's now taking it to another dimension that's also going to give us numbers from minus infinite to infinite, and therefore we create a two-dimensional space. Okay, and so in the coordinate plane, which is the one we have here, we've got 4 quadrants. We've got the X plane and the Y plane. We've got a point that's called the origin where both of them intersect. And we've got positive numbers horizontally going to the right. Negative numbers are going to be to the left. Positive numbers are going to go up and negative numbers are going to go down. So we've got 4 quadrants. Depending on the quadrants is going to be a series of coordinates that we can place there and the signs of these coordinates. This is also known as the XY plane, the coordinate plane, or the two-dimensional space. Now I'm going to give you a bonus for the exam. I'm going to ask you to talk to me about René Descartes. René Descartes was the person that is attributed to the Cartesian plane. Okay, so in the exam, there's going to be a section where I'm going to ask you who was René Descartes, and what I want you to do is you're going to write there a brief bio, but you cannot copy paste it. So you're going to have to write it, and you're going to have to memorize a few points. And if it's well written and clearly written, then I'm going to give you some bonus points on the exam. Okay, give me a moment here just to unhide some slides, and so we can continue. Okay, one moment here. Okay. There we go. There we go. Okay, so now that we're talking about the coordinate plane.
Professor, I'm sorry.
Yes, go ahead.
I have a question.
Mm-hmm.
René Descartes was the one that discovered how to plot the points on the plane.
Well, that's kind of a way of looking at it, but remember that in the past there were a bunch of people who were attributed with a bunch of advances in math and physics. So René Descartes is one of them. So if you read his bio, he was a person that was involved in many things and many research a long time ago. And one of the things that he's attributed with is representing numbers in a two-dimensional space. And that's why it's called the Cartesian plane. So any representations of numbers in two-dimensional space, because before this, we were talking about the number line, Estrella, and the number line is one-dimensional. So the Cartesian plane, now we're adding another dimension. So it's two-dimensional space, okay? And that's one of the things that René Descartes worked on, okay? And so just research a little bit about that. And if you put a bio in the exam, I'll count that.
Yeah, okay, thank you.
Okay, now coordinates of a point, okay? So now we're going to represent, how do we represent a point in the Cartesian plane? Basically, we're going to have a coordinate, and the coordinate is going to be comprised by 2 points, by 2 numbers or values, A and B. These are real values. And so the first value is going to be the horizontal or the X. The second value is going to be the vertical or the Y. And so we plot the coordinate by identifying the intersection between these two. And depending on the quadrant where we're located, is the value of the coordinate combination. So if we're in the first quadrant, both values are going to be positive. If we're in the second quadrant, the x value is going to be negative and the y is going to be positive. If we're in the third quadrant, the x value is going to be negative and the y value is going to be negative. And if we're in the fourth quadrant, the x value is going to be positive and the y value is going to be negative. So any of these combinations actually give us the 4 different combinations of the sign values depending on the quadrant where we're located. Now, how could we plot points? So I'm going to give you 1 minute to try to do the plot of those points that are in example number 1. And I also want you to try to do number 2, which says, sketch the set of points in the XY plane whose coordinates satisfy both of these conditions. Okay, so I'm going to give you 2 minutes to try to work on these and then we're going to solve them here.
Sure.
Yes, go ahead, Jose. Remember to turn on your camera if you want to produce. There you go. Thank you.
I
What's
think I got the first one.
You have it? Okay. I'm going to give you guys a couple of minutes and then we're going to corroborate with what I have here. If you, can you do a screen share, Jose? So do you have it in your computer so you can show it to us?
What? The quadrants
The solution.
for the example?
Yes.
No, but I have it in my head. It's just naming the quadrants, right?
It's identifying the points and naming the quadrants, okay? So I'm going to give you guys 1 more minute, and then when we go to the result, I'm going to ask you the quadrants, okay, Jose? Okay, so let's see what we have here. So in the first case, or let's see, Jose, you were mentioning, you know in what quadrants are each of the coordinates before we plot them. So let's see, Jose, in the point number A, or point A, I'm sorry, what quadrant would that be in?
It will be the first one.
Correct. What about the B?
Second.
Correct. And C?
Third.
Correct. And D?
First.
And E?
First.
Okay. Perfect. Let's go see what we have there. Thank you, Jose. And so notice that we've got the 5 points located here. There's a thing about D and E. These are actually located between 2 quadrants. So if you notice, D is located right on the y-axis. So it's actually between quadrants 1 and 2, and E is located in the x-axis, which is actually between quadrants 1 and 4. Okay. Now, for example number 2, it says sketch the set of points in the XY plane whose coordinates satisfy both 0 less than x is larger than 0 and less than 2 and the absolute value of 1. Okay, so first, the range of values from 0 to 2 in the x plane are, I'm going to mark these here, and I'm going to mark them with a highlighter. So the values that are from 0 to 2, and remember that this is just identifying the number line, are going to be these values here, okay? All of these values here. And this is regardless of the value of x. These are all of the values that are less than between 0 and 2. They're going to be all of these values here. And they're actually also going to be all through the negative. But the other restriction that we are given is that the absolute value of y equals 1. For what values does that occur? It occurs here and here, where we have the absolute values of 1, which is 1 and minus 1. So the resulting combination of these restrictions is going to be the line, or the blue line there, that indicates that the range where both of these comply with is this section here. So this line that we've identified is both between 0 and 2, and also it complies with the absolute value of y, in this case the vertical axis, which is 1. And so we can also represent sections. We can plot points, but we can also represent sections in the Cartesian plane or the XY plane that represent certain values or certain ranges or certain restrictions. Now, these can be defined actually by inequality. So let's see these two. We've got two plots here. One that says XY is less than 0, and the other is the absolute value of y is larger than or equal than 2. So what does the first one mean? It says that xy is less than 0, okay? This means that the multiplication of x and y has to be what? What is the sign of the multiplication of x and y?
Negative.
Negative, correct, Jose. The multiplication of x and y has to be negative, okay? Under what conditions does that occur? If x is positive and y is negative, then the result is less than 0. If x is negative and y is positive, then the result is also 0. In what quadrants do both of these situations occur?
If x is negative and y positive, it will be in the second quadrant.
Correct, perfect. It would be the second quadrant, so it would be this quadrant here. This complies with the inequality. And what would be the other quadrant that also complies with the inequality?
That will be the fourth. The other?
So I'm sorry, no, well, this one that I've marked here is this one.
Yes.
It's x negative and y positive, and the other would be x positive and y negative would be.
Oh, so it will be a fourth.
The fourth quadrant, which is here on the bottom. So these two are going to comply with the inequality that's stated. All of these two quadrants. Okay. This quadrant is this one here, and this quadrant is going to be the one that's over here. Okay. And now for the other one, we have that y is larger than or equal than 2. So the absolute value of y is larger than or equal than 2. So first off, let's identify for what values the absolute value is 2. Go ahead, Jose.
It can be 2 or more.
It can be 2, but also minus 2, because we're talking about the absolute value. okay?
Yes. Uh-huh.
And so the region that's going to comply with this inequality in this case is going to be all of the values that are larger than 2, okay, which is going to be all of this region here, all of the values that are greater than 2 or equal, and all of the values that are less than -2, because we're talking about the absolute value. Okay. And so the region is defined by an inequality that's given by this number here. That can be either positive or negative. Okay. And so what we're doing now is that previously we had only been working in one dimension. So we were only looking at the number line and values that were in the number line. Now we're combining, it's like we combine 2 number lines that intersect, and we're seeing all the possible combinations that can be represented in this combination of actually 2 number lines, which is the Cartesian plane, okay? And that's also here in the PowerPoint. Now, we already looked at the formula for the distance between 2 numbers, right? However, that formula was in 1 dimension. So the distance between 2 numbers is going to be the difference between 2 numbers. But what happens if now the 2 values, instead of being 2 numbers, are 2 points that are located in the XY plane? And so what we do is that we do an extrapolation of the distance formula for 1 point, or I'm sorry, the distance formula for 2 points in 1 dimension, and we take that to the 2 dimensions. And actually what we get in the end is a version of the Pythagorean theorem. So if I've got 2 points, point 1 and point 2, that are located in the Cartesian plane, so I've got point 1 here, and I've got point 2 here. Using the formula for the distance between 2 points, I can find the x distance, which is given by this length here. And I can also find the y distance, which is given by this length here. And so if we notice, what we're generating here with these 2 distances is we're generating a right triangle. So what is the distance between the 2 points? It's going to be the hypotenuse, which in this case is d. And so the hypotenuse is going to be represented by the Pythagorean theorem this way. Now, something that's curious about that's a property that we can apply for the absolute value is that if I have the absolute value of A and I elevate this to the square or any number, I'm gonna represent it this way to actually be, I'm elevating this to any number n where n is even. Okay, so 2, 4. What happens if I elevate a negative number to an even power? What happens to the number automatically? If I elevate -2 to the 2, what happens there?
It becomes positive.
It becomes positive automatically. So if I have an absolute value elevated to an even power, then I can eliminate the absolute value. Okay, and that's what's happening here. So the distance between 2 points x and y is given by this expression, which is the difference of the x's elevated to the square plus the differences of the y's elevated to the square root, which is a variant of the, or an application of the Pythagorean theorem. And so let's see a couple of examples. Find the distance between the points A, 8 and -5, and B, 3, 7, okay? And the other is determine whether 3 points, they're giving us 3 points that are located in the Cartesian plane. By the way, by default, if I have 3 points in the XY plane, they are automatically going to form a triangle. That's If I put any 3 points in the XY plane and I join the points, they're going to form a triangle. That's a. However, we don't know if that triangle is a right triangle. There's 3 types of triangles: an isosceles, an escalene, and a right triangle. We don't know what type of triangle it is, but it's going to form a triangle. So let's look at example 4. So we've got 2 points, 8,5 and 3,7. And so what we're going to do is that we are going to apply the expression. And so the first part of the expression is going to be, I'm going to call this point P1, and this point here is going to be P2. By the way, we can name them however we want. So any point could have been 1 and any point could have been 2. It doesn't matter. We just have to be very careful as to how we represent the magnitude. So this is going to be point 1 and point 2. And so the expression is going to be 0.2, okay, in the X and the Y, minus 0.1 in the X and the Y also. So minus 0.1. And applying the formula, we get minus 5 to the square plus 12 to the square. It's 169. The root of that is 13. And so the distance between A and B is going to be, in this case, 13 units. Okay, just applying the representation of the Pythagorean theorem for the distance between 2 points. Now the other problem said, how can we determine if 3 points are vertices of a right triangle? We know they form a triangle. We don't know if they form a right triangle. So what do we do there? First, we place the 3 points on the XY plane. We place them. So here's point 1, point 2, and point 3. We're just plotting them. And then we join them. Now, from the figure, I still don't know if it's a right triangle or not. Okay. So what we're going to do is calculate all of the distances. We're going to calculate all of the 3 distances of the triangle. So we calculate the distance between point 1 and 2. That's the square root of 125. We calculate the distance between 2 and 3. That's 10. We calculate the distance between 1 and 3, and that's 5. And then if the triangle is a right triangle, then the Pythagorean theorem has to apply. So the sum of the square root of the sum of the squares of the smallest sides has to be equal to the largest side. So if we represent that in the Pythagorean expression, we find that the 2 smaller sides elevated to the square, which is 5 and 10, is equal to the larger side elevated to the square. So since the 3 sides comply with the Pythagorean theorem, we find that it's a right triangle. There's a few problems like these in homework task number 3, actually. Okay, and so these are some applications of the distance between 2 points. Okay, but taken to the 2-dimensional plane. And lastly, we're going to see the midpoint formula. So we saw the midpoint formula for 2 points that are in 1 dimension in the number line. Now the coordinates of a midpoint of a line segment that's in 2 dimensions, we basically do the same thing. We use the expressions to represent the midpoints of each pair of coordinates. And actually the midpoint is going to be the midpoint of the X coordinates and the midpoint of the Y coordinate. So the midpoint of both, that's going to give us the coordinate of the midpoint for the segment line. And so let's assume that we have the coordinates of 2 points. A is minus 2, 5, and B is 4, 1. And we want to find the midpoint for these. So first we plot them. We've got A and B plotted in the Cartesian plane, in the XY plane. And so we find the midpoint for the X's, which is given by the difference divided, the sum divided by 2. So it's 4 minus 2 divided by 2. And then we also find the midpoint of the Y's, which is going to be 1 plus 5 divided by 2. And that gives us the coordinate 1, 3, which is going to be the midpoint. Okay, so it's just the representation, the same representation that we had previously, but now with in 2 dimensions. Okay. So this concludes this last section of Unit 1 that has to do with these expressions to represent values in the XY plane, but also the relationships of distance between 2 points and midpoint, both in the 1 dimension and 2 dimension.